Hey guys, what's up? My name is Gabe and this is Games with Gabe, and this is the next episode in the C++ for Java developer series. So, in this episode we're going to build on what we did in the last episode. Basically, creating a Visual Studio project in your own directory and working on it by yourself is perfectly fine, but there will come a time, I'm not going to say there might, there will come a time when you want to share your code with somebody else. And in order for them to get it running, you don't want them to have to install your exact Visual Studio project because things will most likely break. They will have invalid file references. You know, Visual Studio might be referring to things using absolute file lengths, and you don't want to do that. And so you want some way to basically say, hey, generate a Visual Studio solution for whoever wants to build this code. So that is exactly what we will be going over in this tutorial. We'll be building a batch script that basically says you have this action, you can generate any of these different things. So you can generate a Visual Studio solution for any of these versions of Visual Studio. You can generate something for Xcode, which would be Apple. You can also generate make files for GNU, for POSIX, MinGW, and Cygwin. We might change this as just for Linux distributions of make. And we'll talk about what all this stuff is too. But basically, if I go ahead and I say build.bat and I have VS 2019 on my machine, then we get this solution file. Okay, and if I were to click into this solution, then it will open up a brand new project, which has all my settings configured just the way I like them without me having to do anything. And if I open up my thing over here, first of all, click this button. Like I said, always click that button as soon as you open something. We have our logging solution. And if I hit debug, we get our logging solution printed out. Okay, so that was super nice. If I was a user or if I was downloading this code, I wouldn't have to have this file on my machine. It can be generated now, which is amazing. We can also do something like this, where we can say build.batch clean. And what that will do is you'll notice that has removed all the Visual Studio solution files, the binary directories, the binary intermediate directories. That's also very nice because it allows you to clean up the code before you release a distribution or whatever. And then we have the final option to say build.batch compile, which will basically generate the Visual Studio solution file, and then it will go ahead and compile it. You see we get a binary directory over here too, which is very cool because then you immediately get your executable and for now your PDB. You could add options to build a release version or a debug version, whatever you want to do, basically by modifying this batch script. So this is a very versatile solution. It's really nice because it allows you to clean up your code very quickly, allows you to distribute this code very easily, and allow somebody to generate one of several different solution files where they can use any of these versions of Visual Studio, Xcode, make files, whatever they want to do. So the way we will be accomplishing this is using something called Premake. This will be linked in the description, okay? What I want you to do is download version 5.0. It should be just an executable. And then also go to the user guide, peruse this because there is so much great resources here. What is Premake? Getting Premake, using Premake, building Premake. Okay, this is seriously great documentation and it is very helpful. If you ever have any questions, go here. This will most likely answer whatever question you have and allow you to accomplish whatever you're looking to accomplish. So how do we actually go about creating a Premake file? I'm sure you don't want to go through all that yourself, right? This is a tutorial you came to learn about this. So let's actually go ahead and do this. So I'm going to go to our directory. I was in a copy of our directory and we will go ahead and redo what I did there. Right now we have it sort of like this, right? We have this build.batch file and then we have all of our files just sort of in here. First thing I'm going to do is clean up our folders a little bit. So first I'm going to create a folder called practice project, which will be our project folder, right? This is where all of our source code will live. So I'll go ahead and move everything in here. You may have multiple projects too. So if you had another project, which was a library, like maybe you had a math library, you could put that in here and that's where I would suggest you putting it. And this is basically the root of your multi-project directory. So inside of here, what I typically do is create a CPP. You could create a source directory if you like. I just like CPP because that is what it is, I guess. You know, it really doesn't matter too much. And then over here, I'll create an include file, just like we did for our Visual Studio solution, okay? And I'll move our log.h file into there. Now, the way Premake works is it is operating based off of Lua, okay? And so we will create a vendor folder in here. And if you download that executable, I would suggest just putting it in a Premake folder and having Premake 5 there. So I'm actually going to just copy that because there's no reason for it to look like this. Copy that executable into your vendor folder. This is all we need to run Premake, which is really nice. And you can use the Lua programming language and it should work just fine. And then the next thing Premake expects is there to be one file inside of your root called Premake5.lua. Okay. And then for every project you want to include, you would also have a file in here. We'll create another new file. Call this Premake5.lua. Okay. This is very similar to how CMake or Make or something works, where you basically have recursive includes for every project. Okay. Now, let's go ahead and open this up in code and actually start creating Premake solution. So I'm going to go ahead and open code, and then I'll go to our folder, which is right here. Then we should see Premake5.lua. Sweet. Okay. So the way you typically start building a project is you have a workspace, which is basically like our Visual Studio overall project. We'll call this workspace for now, just so that we can see how all this works once we actually generate the Visual Studio solution file. Then we are going to target an architecture. Okay. You could list multiple architectures here. I'm just listing x64. You could list x64. And I believe it would just be something like this, and you would say x64, and you want to target x86. So that's 32-bit, that's 64-bit. I'm just targeting 64-bit because the amount of 32-bit machines still out there is quite low. So I don't think you have to worry too much if you just target 64, but the option is there. You don't have to listen to me. Then we can define any configurations we want, right? So I want to have a debug configuration and I want to have a release configuration, and you could put whatever other configurations you want. And we will see how these relate in Visual Studio Solution File once we create that. And the last thing we're going to do is say we want a start project, which is our practice project. That's the project we want to be in when we open up the solution file. Then another thing I like to do, which I copied directly from the Cherno, is create this output dir thing. Okay. And you basically say, I want this to be configuration.build configuration. And this is Lua, just straight up string concatenation and string formatting. So this is how you would do that in Lua, I believe. And then we will use cfg.system. And these are all just variables that Premake gives us, right? So we'll be build configuration -system -configuration.architecture. Okay, so if you built debug for architecture x64 on Windows, I believe this should say Windows, debug Windows x64. And then if you did x86, it would be Windows debug x86. And if you did release, this would change release. So that's basically what we're doing, is we're just creating a very simple solution to name our directories. Then we're going to say include practice project. But we have no way to include practice project, right? So we have this directory over here, which has a Premake5.lua file. What is going to end up happening is this will go into the folder practice project, look for a Premake5.lua folder, and it might not even go based off of the actual directory names. It's just going to go look for another Premake5.lua file that has this inside of one of our subdirectories. I believe that's how it works. I could be mistaken on that. Just keep it simple and name it the same name as your directory if you want to keep this simple, okay? Anyways, let's go into here, and then we're going to define a project. We'll say, hey, we have a project in here called practice project, right? So the same name as our directory. It's also the same name as the thing we want to include here. We're going to say that this is a kind of console app. You could also make a shared library. You could also make a static library. This is basically what kind of thing you're producing. And I would suggest keeping it console app until you know what the difference between all these different things are. Next, we'll say language. We're using C++. The reason they have this is because you could also generate C# solution files with Premake. So just use C++ unless you're using something else. Then we'll say CPP dialect is C++ 17. There are different dialects of C++. C++ 17 is just the 2017 version. I believe C++ 20 is out now. There's also 14, 11, and I think before that is 03, but I'm not sure what that would be called. So basically it just goes based off the year, and I use C++ 17, which should be pretty good for most libraries if you want to use an external third-party library. Last thing I will specify, but it's debatable whether you really need to, is say static runtime is on. This basically says that if you are importing extra libraries, you are statically importing them. We're not importing any libraries, and I don't know if this actually does do anything if you're not. So debatable whether you actually need that flag for simple projects like what we're doing. Okay, now we're going to get to some good stuff. We're going to say our target directory is .. /, right? Because right now we're inside a directory. So we want our final output to be in the root of our project structure, right? We're in here right now. We want our project to end up out here. Like we want it to generate a bin directory and a bin int directory out here. So we can say target directory is /bin, so out one directory. Then we'll do a .. which is concatenation in Lua. Output dir, so it'll do that whole string that we want. And then we'll say /%prg.name. So if you have multiple projects, this will take up practice project. The next one would take up, if it was math library, it would say math library. So, and it would put that in the correct folder, which just streamlines your whole process. And then we want an object directory. Object is the object files or our intermediate files. So we'll call /bin int output dir /prg.name, prj. Okay, so basically we set up where we want to put our intermediate files and our final executable files, and this will do it all automatically. Super nice, okay? Now we define where our files are found. We need to tell it where to find all of our include files, all of our CPP files, so they get included into our solution. Well, that's pretty easy. We have all of our include files in **.cpp. That is a wildcard to match anything that ends in a .cpp within any subdirectory. If we do *1*, this will match anything in the directory immediately in CPP. We want to match all subdirectories, so this will basically recursively search. And that was one feature that CMake does not have, Make does not have very easily. You can do it, but it's not easy, and that was one of the reasons I chose Premake, among many others. Okay, then we can do include /*.h, which will include all of our H files. You could also add include /*.hpp, which is another common file extension. But if you're not going to create any files like that, there's no sense doing this, right? We could just leave that, which I will. Then we could say defines, okay? And any definitions you have here, say we want to define windows, we could put here. We could also put whatever else you want to put in here, okay? And you can target specific systems, which I won't go into yet, but basically you could say almost something like filter. I think it's similar to this, system, Windows, and then if you indent this guy one more, then this will only be defined on Windows. We'll talk about that in a future video if we actually get to a point like that. But basically, yeah, we can have custom definitions for custom platforms all defined right within here. Then we're going to say build options, and I'm going to do /mt. Okay, I am actually going to use the filter here because it does just make sense. So we'll say filter for system, Windows, and we'll do configuration debug. So you can specify a configuration and a system. And actually this is going to be the same across systems, I believe. So we'll just say build options /mt for debug. And actually that is a /mtd for debug. And then we'll do a filter with a configuration release. And we're going to say build options /mt. Okay, this is basically just setting up the memory pool that your program will be allocating from. This is some more advanced stuff. I won't talk about this too much, but just make sure that you set it to this for now and it is consistent across projects. If you have multiple projects, make sure they are all /mt or /md. And there is a difference when you would use one over the other. The D is just for debug, so that's kind of easy, and the no D, not debug. And then we're going to do just a couple more things in here. So we'll just say runtime for debug is debug, right? We clearly want debug on, and we want our symbols on. So this basically says generate debug symbols, and we're using a debug configuration here. For release, we do not want that, right? We have a runtime of release, and we would like to optimize because we're releasing our code. So we can say optimize on, and that will give us a bunch of compiler options that will automatically optimize our code. There's so many more options that you could do here. I am not going to go over them all because it is listed in the documentation. This is just sort of a simple project setup that I like to use that gets you started fairly quickly. Okay, so now how do we actually build this? Let's go ahead, and if we look into here and you have your command prompt opened up in here, what you can do is you can just say vendor/premake 5.exe, because this is an executable. And as you can see, it's telling us right off the bat that we have an error in our Premake 5 file on line 19. So right in this one is the one I believe it's telling us. Yeah, so it says this is an error. And that should be configurations, not configuration. Okay, so if we run this one more time, I will pull up the file explorer so we can see what happens. If we run Premake 5. Okay, so it says type in help. So let's do that. We'll say help. Gives us all these different options that we can use. Most of these you probably don't really need to use. This is pretty cool. It has a debugger and everything that you can start. Yeah, we don't really need any of that stuff. What we really care about are these actions, right? And so basically you can generate solution files for any of these, which is where I got that from. And we'll sort of build a build script made around this. For now, let's just say, instead of help, let's generate one for VS 2019 or whatever version of Visual Studio you have. Okay, it says running actions, and then we get a thing called workspace. We called it workspace right here. That is why it generated something called workspace. If we open this up, we can see what it generated and how it relates to the code we wrote inside of our Premake files. So you can see that we have one project over here called practice project, which is what we called it in our subdirectory. And inside of here, remember, click this, always click this. Never forget to click that because you will hate yourself if you don't. We have this CPP and these include directory, and we have all of our files listed. If we click one of these, it'll open up our file. So we've basically created this. Okay, we have this error again. How can we fix this? Well, using Premake, this is so much easier. What we can do is we can call something include dirs, right? We basically had to add an include directory to get this to work properly when we were doing Visual Studio, go through the options and everything. So much easier. Just add an include directory here called include because that's where we want to include it from, right? It's just this. Let's run this one more time. Then if you click on a Visual Studio, it'll say, do you want to reload? Hit reload all. Now that error is gone, just like that. So much nicer, so much easier. We didn't have to worry about going into the properties panel, any of that stuff, and then run into all these problems. And you can see that we compiled it and it ran perfectly fine. So that is pretty cool. That was not too difficult either. Let's create a build script, or yeah, a build script inside of our batch file to sort of automate this a little bit better. First of all, we'll say echo off. And then we'll go ahead and we'll say if there is no argument. So the way you can check that, if the user typed in a argument after the build script, just do a %(1). That will give you argument 1. (2) is the second argument, (3). So we can say if this equals an empty string, we'll go to print help, because if they didn't enter anything, they probably need help. Then we'll say if %(1) equals compile, we'll do some special compile step, and we'll actually do lowercase compile. So we'll say go to compile. Otherwise, if they entered in just something like Visual Studio 2019 is what we're assuming, then we'll say vendor/premake, or actually just premake 5.exe, and we will just pass in whatever they passed in. So we'll just say %(1), which is whatever they passed in. And if that's an error, that will throw an error if they passed in something invalid or whatever. Then if they don't, we'll create this little go-to statement, print help. And right here, we'll say go to done, because we don't want to print the help if they did this correctly. So then we'll just create another little branch in here. If you don't understand batch scripts and stuff too, this is not a batch script tutorial. This is some pretty simple stuff. This is a go-to statement that you can use and to sort of simulate if-else statements and stuff like that. Hopefully it's pretty straightforward. I hope so. Okay, let me know if I should go over this in a little bit more depth. For the print help, I am just going to copy this large thing, which you can also copy if you want from a link in the description, because I don't think it's worth just typing all this out manually, and I don't think you would like that either. It's basically just telling you what to do. Compile says it will compile, it'll do all this. Clean will do this. And then it gives you all the different options that you can do. And you can actually add in Gmake, and we can change this to, I believe, Linux. We'll double check that. I'll double check that and then update you guys in the next episode. Okay, and then if this, we go here, then we'll say go to done. Then we'll create one more little location. So compile, right? If they typed in compile, we have to sort of do something a little bit more manual. We'll say this. If they typed in compile for now, what we can say is just execute premake 5.exe VS 2019. So we'll automatically build a VS 2019 file. You might want to expand this in the future to use whatever they normally passed in. Look for something on their system. Make this a bit more of a smarter, more robust build system. I'm just making this very simple because there's no reason for me to make this complicated right now. And then what we can say is if not defined, dev env dir. This is very important because otherwise you will eventually get errors if you leave a command prompt open for a long time. What we're going to do is we're going to say call, and let's actually go ahead and look for this directory. So if you go into C, if you're on Linux or Mac, this may be different, or Mac, Linux won't have this. But basically we'll go into program files, x86, so 32-bit files. Then if we go to Visual Studio, which is right here, Microsoft Visual Studio, and then we go to 2019 in Community, Common 7, Tools. Then inside of here, we have this thing called, let's see where this is, vsdevcmd.batch, okay? Shift right click on this and hit copy as path. Then paste it right here. We're gonna call this thing, which will basically, you know how we always had to type in dev here to open the developer command prompt? Well, this does the same thing, except we're just automating it so that you don't have to do that, right? Because it's annoying. And this basically says if it hasn't already been called, then call it. That way we don't call it over and over and over again, which will cause problems. If that's true, then we'll say set solutions, solution file equal to practice. Or actually, I think we called it workspace. So we'll say workspace.sln. And then we'll say ms build, which we get because we called this. So now we have access to ms build. T, we'll say /t build, and then we'll say /p configuration equals debug, and you can change this or make more options if you want. And we'll say platform equals x64. Once again, you can add options, do whatever you want. And we'll say solution file, %solution file %. So basically this will just build using ms build our whole solution. Okay, so let's try this real quickly. If we do build.bat, it says enter an action. So then if we say build.bat vs 2019, it says it's building. It builds it using Premake. And then if we do build.bat compile, we see that it's building. And then it calls vs or ms build, and it goes and compiles that solution file for us. So this is one neat way to automate this whole build process for you. That way you don't actually have to open up Visual Studio if you just want to compile it on a friend's computer or whatever you're doing. Or if somebody else wants to download it and compile it without having to worry about this stuff. Last thing we need to do, which is the clean. So it says clean, the clean action has not yet been ported. What's this saying? Well, basically, if you want to add custom actions into Premake, you can do that. What is a custom action? It's basically you typing in something that doesn't support out of the box. And so you can basically just add in any extra stuff you want to do by doing new action. And this is just Lua code, right? We'll say trigger equals clean. And then we'll say execute, or actually description. So we'll give it a description too. Description equals remove all binaries and intermediate binaries and Visual Studio files. Okay. And we need a comma into these. And then we'll say execute equals function. And we'll just do a bunch of stuff in our function. So we'll say print removing binaries. Then we'll say os.remove directory ./bin. So that should remove all the binary files. Then we'll say print removing intermediate binaries. And then we'll say os.remove directory ./bin-int. Then we'll say print removing project files, and then we'll remove all the project files here. We'll say os.remove dir ./.vs, which is a Visual Studio directory. And then we'll say os.remove, and you can do wildcards in here, which is nice. So we can say **.sln. This will remove all solution files recursively. And we'll say os.remove. We want to remove everything that ends with VCXPROJ, which is a Visual Studio project. Remove **.VCXPRJ.filters. And this is all stuff that you would want to put into your git ignore as well. Just that because you can now generate this stuff, you don't want to ship that with your code. And then the last thing is vcxproj.user. And then we'll say print done. And we will end that function. So this is some things that Premake also provides to us that allows us to do these cool things like wildcards. It's very nice. Now, if we go into our directory once again, and if we go build.bat, clean, it says running action clean, and then you see it says removing binaries, removing intermediate binaries, and removing project files. One thing I noticed that this is not generating correctly, so I lied to you guys somewhere. I go into the Premake 5 Lua over here. This should be bin/. That's better. Now, if we run this one more time, we'll say, first of all, if you say Build.bat compile, you see we get all those files in there. We get the workspace, we get bin and bin int, and they are formatted correctly so that if you actually click into it, now we get this stuff. Then if we go ahead and say Build.bat clean, and we also get this too, which says, which gives us the warning, right? So we get this warning because we had something in our code, the cast, right? So that's pretty cool. Then if we go ahead and clean this, then it cleans everything up and we no longer have any of that stuff lingering around. For your practice project, I just want you to practice with Premake, okay? Create a different folder in here, also a console project, call it math library or something, and then create some C++ code to do some math functions. Try and do it from scratch by looking at the documentation instead of looking at this file that I've provided you. Add some different options, some different compiler options, some different definitions, and just play around with Premake, see how all this stuff works, and make sure you can export this stuff. Then create a Git repository if you are familiar with Git. Export just the generation code, which would be our batch file in our Premake files and our source code, and see if you can ship your code that way and get it in a fresh directory and build everything really easily. That is it for this tutorial though, guys. If you have any suggestions, comments, whatever, leave them in the comments below. And if you like this, please hit like and subscribe. And I will see you in the next episode where we will finally be going over structures and namespaces. And I will see you guys then.